Hello, hi, good morning, all of you. So, this is the second lecture on the previous JEE mains papers. So, today we are going to learn about the dual nature of radiation and matter. సో ఈ చాప్టర్లో 2020 సెప్టెంబర్ మంత్లో ఏవైతే క్వశ్చన్స్ ఆస్క్ చేశారో ఆ క్వశ్చన్స్ని ఇప్పుడు మనం సాల్వ్ చేస్తున్నాం. సో ప్రీవియస్ వీడియోలో యూనిట్స్ అండ్ మెజర్మెంట్స్ నుంచి ఏవైతే క్వశ్చన్స్ ఉన్నాయో సాల్వ్ చేసాం. మీరు చూడకపోతే ఈ వీడియోలో ఐ కార్డ్స్లో ఇస్తాను, మీరు తప్పకుండా చెక్ చేసుకోండి. అండ్ ఈ ఛానల్ మాత్రం డైలీ ఫాలో అవ్వడం ట్రై చేయండి. మీకు ఈ 45 డేస్లో ఏవైతే మనం ఇంపార్టెంట్ టాపిక్స్ మనం డిస్కస్ చేస్తున్నామో ఆ టాపిక్స్ నుంచి రోజుకు ఒక వీడియో మీకు వస్తుంది. దయచేసి అందరూ ఫాలో చేయండి. So now let us start our topic. Dual nature of radiation and matter. So this is our topic today. So at first we have to learn about some synopsises. So in this mainly we have to focus on photoelectric effect. Photoelectric effect. The sufficient light energy will be incident on the surface of the metal. Then the electrons are ejected from that surface. That phenomenon is known as the photoelectric effect. Okay. So here we have to focus on threshold frequency. What is that? Threshold frequency. And the second one it is work function. Threshold frequency and work function. Okay. And the maximum kinetic energy. Maximum Ke or Ke maximum. Okay. So what is the threshold frequency here? Threshold frequency it is nothing but the minimum frequency required which the electrons are ejected from the surface of the metal. So where frequency nu is equal to nu naught, then electrons emitted with zero kinetic energy, with zero Ke. Very important. If nu is less than nu naught, where nu naught is the threshold frequency, here nu naught is the threshold frequency. So here no photoelectric effect, no photoelectric effect. Okay. And whenever nu is greater than nu naught, here the electrons are ejected, and with sufficient kinetic energy, with finite kinetic energy. So here zero kinetic energy. If nu is equal to nu naught, electrons are ejected and kinetic energy is zero. If nu is less than nu naught, the frequency is less than to the threshold frequency, then there is no photoelectric effect is possible. If frequency is greater than to the threshold frequency, then the electrons will be ejected and with finite kinetic energy. Okay. And here work function. The work function W it is equal h nu naught, where h it is the Planck constant here, Planck's constant, which was 6.62 into the basic value of 6.62 into 10 to the power minus 34 joule second. 34 joule second. And nu naught is the threshold frequency here. Threshold frequency. And this is also known as the relation between the work function and to the threshold frequency. Work function and to the threshold frequency. Okay. Right. And Ke maximum. And the kinetic energy, the maximum kinetic energy is the potential of the electrons. It is EV. It is equal to Ke maximum. So the potential is numerically equal to the maximum kinetic energy. Okay. And then the important point it is the wavelength, threshold wavelength, where the wavelength of the electrons. So lambda it is equal h by p. So this is the de Broglie's wavelength. This is the de Broglie's. Right? So p it is the momentum. P it is the momentum. Where p it is equal, it is m into v. Therefore we can write that lambda it is equal h by mv. Lambda is equal h by mv. We can write that. So lambda is equal h by mv. Okay. Here mv should be written as energy E it is equal to 1 by 2 mv square, where so in both sides m multiplied by the m, then me it is equal to 1 by 2 m square v square. Okay, here m square v square it is equal to 2me. Therefore mv it is equal to under root of 2me. Okay, so then you can write lambda is equal h by p it is equal h by mv refers under root of 2me. So where E it is the kinetic energy, E it is the kinetic energy, or we can write that Ke also here, Ke. Okay, so this is the lambda. Here the relation between lambda and to the kinetic energy, so lambda inversely proportional 1 by root Ke and lambda inversely proportional 1 by root m. Okay, so these are the relations. Here we have to see. And the energy should be written as here W it is equal, energy it is equal, E is equal h nu. E is equal h nu. So now we have to write the photoelectric effect, which is from the Einstein's equation. So Einstein's photoelectric effect says that the energy which is given to the surface of the metal is utilized to work function into the kinetic energy of the electrons. Okay, so here we can write that Ke maximum it is equal to E minus W. E it is the energy, it is nothing but h nu. E is equal to h nu, and W it is equal to h nu naught, which is h nu naught. Okay, so this is Ke maximum. So this is the photoelectric equation, Einstein's photoelectric, where nu frequency it is equal to c by lambda. Since you can write that Ke maximum is equal to hu c by lambda minus hc by lambda naught, hc by lambda naught. Right? So this is the Ke maximum. So these are the basic terms we have to know before we are going to learn about some numericals. Okay? Right. So this is the question which was asked in 2020 September 2 shift 1. Okay. Right here, when radiation of wavelength lambda is used to illuminate a metallic surface, the stopping potential is V. Already we denote that the stopping potential EV it is equal, numerically it is the Ke maximum. Ke maximum. When the same surface of the surface is illuminated with potential is V by 4. Here it is the V and here it is V by 4. Where the stopping potential is V, the wavelength is lambda. If the threshold wavelength for the metallic surface is n lambda, where the stopping potential V by 4, then the threshold wavelength it is the n lambda. Then the value of n will be solution. It is here the radiation of wavelength lambda wavelength lambda, work function is phi naught, let it be phi naught, and stopping potential it is V by V, stopping potential is V. Hence the equation it is Hc by lambda minus phi, it is equal EV. So here E minus W, it is equal Ke maximum. This is the Einstein's photoelectric equation. E, it is the energy, that is Hc by lambda h nu, and W, it is the work function, here phi naught we have to say, and EV, it is the stopping potential, where stopping potential numerically is equal to the EV, right? For coming to the second one. So what is the second one here? The radiation of wavelength, whereas 3 lambda wavelength. So here 3 lambda wavelength, and then the stopping potential is V by 4. Therefore Hc by 3 lambda minus phi naught is equal EV by 4. Okay, so this is equation 1 and this is equation 2. So the equation 2 should be related to the equation 1. Then we have to, so here Hc, we have to multiply by the 3 on both sides. So 3 into, so then you can write that Hc by lambda minus 3 phi naught is equal 3 EV by 4. I have to multiply on both sides by numerical 3 by the equation 2, right? So now you can write that. So here from equation, so this is now, let it be equation 2. So from equation 2 and 1, we have to write that Hc by Hc minus lambda minus 3 phi naught minus this one, Hc by lambda minus phi naught is equal to 3 EV by 4 minus EV. Okay, now you can write Hc by lambda minus Hc by lambda gets cancelled. Hc by lambda minus 3 phi naught is minus Hc by lambda plus phi naught is equal to 3 EV by 4 minus EV, 4 EV. Here minus EV by 4, minus EV by 4. Okay, 4 will be LCM, 3 EV minus 4 EV. Okay, so Hc by lambda minus 2 phi naught is equal to minus EV by 4. Okay, minus minus gets cancelled. EV is equal to 8 phi naught. EV is equal to 8 phi naught. What is the EV value? EV is equal to 8 phi naught, where just you have to put this value in equation 1. So whereas EV it is replacing by 8 phi naught, then Hc by lambda minus phi naught is equal to 8 phi naught. Okay, right, Hc by lambda is equal to 9 phi naught. Hc by lambda is equal to 9 phi naught. Then you can find, so this is from equation 1. Equation 1. Okay, work phi naught is equal to, already you know that work function is equal to h nu naught, it is equal to Hc by lambda naught. So just simply you can write that Hc by lambda it is equal to 9 into what is phi naught, Hc by lambda naught, where Hc gets cancelled, lambda naught is equal 9 lambda, lambda naught is equal 9 lambda, where lambda naught is the threshold wavelength. So here in n lambda we have to comparing, so then lambda naught is equal here n lambda, where lambda naught is equal 9 lambda, so n is replacing by 9 here, right? So the numerical of here option D is the right answer. So here this is the second question which was asked in 2020 September 2 shift 2. Right? The first question is shift 1. This is the shift 2 question. A particle is moving 5 times as fast as an electron. So speed of the particle, P for particle, we can write that Vp is equal 5 times of the Ve, speed of the electron. ratio of the de Broglie wavelength of the particle and that of the electron. Ratio of the particle and that of the electron is 1.878 into 10 to the power minus 4. The mass of the particle is close to, okay, the ratio of the de Broglie wavelength, where lambda p by lambda electron is equal 1.878 into 10 to the power minus 4. Now let us find the mass of the particle is close to 2. So which are the options are A, B, C, D, here, there, right? So the de Broglie wavelength, lambda it is equal h by p, it is equal h by mv, h by mv. So here lambda inversely proportional mv. Already write that lambda p by lambda e it is equal 1.878 into 10 to the power minus 4. You can write lambda p, lambda is inversely proportional mass into the speed or velocity. It can written as mv ve by mp vp. It is equal 1.878 into 10 to the power minus 4. Lambda p, it is directly proportional to the, it is inversely proportional mp vp. Lambda e inversely proportional me ve. So lambda p by lambda v. So here I can write lambda p it is equal 1 by mp vp. Lambda e it is equal 1 by me ve. Lambda p by lambda e it is equal me ve by mp. Right? So Vp is already wrote that 5 into Eb. You can write Me into Ve by Mp into 5Ve. Ve cancel is equal to 1.878 into 10 to the power minus 4. Okay. Now we have to find the mass of the particle, where Mp from this equation is equal to Me by 1.878 into 10 to the power minus 4 into 5. So what is mass of the electron here? 9.1 into 10 to the power minus 31 by 1.878 into 10 to the power minus 4 into 5. Okay. So now we can simplify that. We will get the value, whereas 9.7 into 10 to the power minus 28 kg. So this is the mass of the particle here, P for particle. Okay. So this is the de Broglie's wavelength, already we discussed at starting of our video. Okay. This is the third question which was asked in 3rd September, shift 1. When the wavelength of a radiation falling on a metal is changed from 500 nm to 200 nanometers, the maximum kinetic energy of the photoelectrons 3 times larger, the work function of the metal is closer to, right? So here the work function values are there. So how we can solve this? Already you know that the maximum kinetic energy. So Ke maximum it is equal, what is that? E minus phi naught. E minus phi naught from the Einstein's equation, where E it is the hc by lambda. it is the hc by lambda minus of phi naught. So this is the Ke maximum. You can write where it is the maximum kinetic energy of the photoelectrons are 3 times larger. Where? Whenever it was falling on the surface of the metal. Okay. So the lambda at first it is the 500 nm and second one it is the 200 nm. Hc value. What is the Hc here? Hc it is 1240 nm electron volts. Okay. Nano electron volts. Nm electron volts. And phi naught is the work function. Phi naught is work function. Right. Now we have to write Ke maximum. Okay. So this is the Ke and Hc by Hc means 1240 by at first lambda it is 500 minus phi naught. This is equation 1. And second one Ke maximum it is equal Hc it is 1240. What is lambda here? 3 times of the first one. It is 200. It is 3K. 3 times of larger. The maximum kinetic energy of 3 times. It is 200 minus phi naught. So from these two equations we can write that K it is already know that 1240 by 500 minus phi naught. 3 into 1240 by 500 minus phi naught is equal this one 1240 by 200 minus phi naught. Just you have to simplify these two values, two equations. You can write 3 into 1240 by 500 minus 3 phi naught is equal 1240 by 200 minus phi naught. This minus phi naught should be here minus 4 phi naught. Okay. 2 phi naught minus 2 phi naught is equal 1240 by 200 minus 3 into 1240 by 500. Okay. So 2 phi naught is equal 3 into 1240 by 500 minus 1240 by 200. Here you can simply 1240 by 100 will be common 3 by 5 minus 1 by 2. Okay. 3 by 5 minus 1 by 2. Right. So here 6 minus 5, 1 by 10. It is 1240 by 100 into 1 by 10 here. Because of 5 2s are 10 is the LCM. And 2, 3, 6 minus 1 by 6 minus 5, 1 by 10. It is equal to 2 phi naught is equal 1240 by 1000. 100 into 10. 1000. Just you have to find the work function here. So therefore phi naught is equal here 1240 by 2 into 1000. Okay, 0 0 cancel. So here 200 124. Right? It is, what is that? 0. 6 2s are 12 and 1 200. So this is phi it is equal 0.61 electron volts. So this is the answer here. This is the question number 4 which is asked in 3rd September shift 2. Okay. Two sources of light emits X-rays of wavelength 1 nm and visible light of wavelength 500 nm. These are the wavelengths of X-ray and visible light. Okay, respectively. Both the sources emit light of the same power. The power it is same, that is 200 watts. The ratio of the number density of the photons of the X-rays to the number density of the photons of the visible light of the given wavelength is. Okay, so now the ratio of the wavelengths we have to find that. That should be, the options are given that, how we can find. Right, so at first we have to write, here it is the power. So power of source is equal, power of source it is equal energy emitted per unit time, that is the power of the source. Okay, so what is the energy emitted? The energy emitted, it is the number of photons into, if for one photon, okay, and divided by, it is time here. The number of photons per unit time, it is the number density of the photon into energy for one photon. These are the formulas you have to remember here. Okay, power source it is equal, source of the power it is equal, power of source it is equal energy emitted per time, energy emitted energy it is equal number of photons into energy for one photon. The ratio of number of photons per unit time, it is the number density of the photon. Okay, so here number density it is the n into energy for the one photon, it is the hc by lambda. Okay, this is the power. So here these two emitted lights are same power at 200 watts. Therefore, power of X-rays is equal to power of visible light. This is the concept here. Therefore, you can write that. How we can write? The wavelength should be here. From this you can write lambda. It is equal to n hc by p. Okay. Right. We can write. So wavelengths of the. Therefore, we can write from this nx hc by lambda x, it is equal to, for the visible, nv hc by lambda v. hc gets cancelled. Nx by lambda x, it is equal to nv by lambda v. Okay. Therefore, nx by nv is equal to, or nv by nx, the number density of the photon of the visible light of the given source. So here nx by nv, it is equal to lambda x by lambda v. Okay. Therefore, it is equal to wavelength of the X-rays, it is what they can give to us 1 nm, and the wavelength of the visible light, it is the 500 nm. That is the 1 by 500, where nx by nv. This is the ratio of the number density of the X-rays into the number density of the visible light. If the number density of the visible light into the number density of the X-ray is equal to 500 by 1, then it is 500. Okay. Right. This is the 1 by 500. This is the 5th question, which is the 4th September. Shift 2. In a photoelectric effect experiment, the graph of stopping potential V versus reciprocal of wavelength, it is 1 by lambda, obtained is shown in the figure, as shown in the figure. This is the y-axis and this is x-axis. On y-axis taken as potential and x-axis reciprocal of the wavelength. As the intensity of the incident radiation is increased, if the intensity of the incident radiation will be increased, what is the shape of the graph? The graph has no change. The straight line shift left, the straight line of the graph shift right, and the straight line which is more straight. So what is the correct answer in these two? So the correct answer it is no change. Why it is no change? Because the Einstein's photoelectric experiment. So by the Einstein's photoelectric experiment, that is energy it is equal to work done plus Ke maximum. So Ke maximum it is equal to energy minus work function. Energy it is phi, work function it is phi naught. Where Ke maximum it is numerically equal to eV. Okay. So here phi it is equal to hc by lambda minus phi naught eV. So V it is equal to hc by E 1 by lambda minus phi naught by E. So this U should be here in this side. Okay. Here you can write. So this should be comparatively to the equation of y is equal to mx plus c. Y is equal to mx plus c. Okay. Here x it is the 1 by lambda, m it is the hc by e, and c it is the intercept. Y intercept is minus phi naught by e. Okay. Slope it is the slope m it is equal, what is that here, hc by e. Okay. Now let us see if the intensity of radiation increases. Intensity of radiation increases. What should be done? Increases. So there is no changes in the H value and the C value and the E value as well as work function value. So these are not changes. No change. Okay. So hence, if there is no changes in these terms, here the slope of the graph should not be changed by the H, C and E, and also intercept of the value phi naught should not be changes. If these two are not changes, the graph should not be changes as well as like as this one. Hence we can say there is no change. Okay, there is no change in the graph. This is the question which was 5th September, shift 1. Okay, a beam of electrons of energy E S is scattered from a target having atomic spacing of 1 angstrom. The first maximum intensity occurs at the theta is equal to 60 degrees, and then E in electron volts is the energy of the electron in the value. Options are given that. So we have to solve that. From the Bragg's equation, you can write 2d sin theta it is equal to n lambda, where the first maximum intensity is occurs at the theta is equal to 60 degrees. The first maximum it is equal to n it is equal to 1, and then lambda it is equal to 2d sin theta. Okay, 2d sin theta, where theta it is the 60 degrees. Right, lambda is equal to, what is lambda here? Lambda is equal to h by nu. Sorry, lambda is equal to h by p. So p it is the momentum. So here h by p, it is equal to 2d sin theta. The p should be written as h by mp. It is the lambda. Okay, so this can be written as, so already you know that energy it is equal to half mv square. So m into E it is equal 1 by 2 m square v square. mv it is equal to under root of 2 m E. Here h by under root 2 m E is equal to 2d sin theta. We need to find the energy value. Okay. Therefore, root 2 m E is equal to h by 2d sin theta. Okay. Right. 2me is equal, 2me is equal, squaring on both sides, h square by 4d square sin square theta. E it is equal, 2m should be h square by 8 m d square sin square theta. Now substituting all these equations, all the values, h it is equal Planck constant 6.62 into 10 to the power minus 34 joule second, 8 into, what is the mass of the electron, 9.1 into 10 to the power minus 31 into d square. D it is the 1 angstrom here, 1 angstrom, it is equal 10 to the power minus 10 meters into sin square theta. Sin square 60 it is equal, sin 60 it is the root 3 by 2. Here sin square 60 it is equal 3 by 4. Here it is the 3 by 4. So let's calculate. We can get the answer nearly, which is 50, which is 50 electron volts, 50 eV. Okay, so this is the energy. So from the Bragg's equation you can write L lambda is equal to d sin theta. For the first maximum intensity n is equal to 1, you have to take n lambda, lambda by p. From the d table is lambda by root 2 m ev. E should be substituted here, h square by 8 md square sin square theta. So it is the direct equation which you have to remember. If it is possible, you have to remember this one. This is the question which was asked in 5th September, shift 2. Okay. Very simple question. The surface of a metal is illuminated alternately with photons of energy C1 is equal to 4 electron volts, E2 is equal to 2.5 electron volts respectively. The ratio of maximum speeds of the photoelectrons emitted, ratio of maximum speeds in the two cases. The first case speed it is V1, the second case speed it is V2. The ratio of these two it is 2. Okay. The work function of the metal is in electron volts. What is the work function of the metal in this case? Okay. Right. So here from the photoelectric equation of Einstein's, so it is the energy, it is equal work function plus kinetic energy. Okay, kinetic energy it is equal E minus W. E it is the energy. It is half m v1 square at first case. What is the energy at first case? The energy E1 it is equal 4 eV minus work function, that is 5. And in the second case, half m v2 square it is equal, how much the energy it is? 2.5 eV. 2.5 eV minus work function 5. Okay, from equation 1 and 2. So this is the equation and this is the equation 2. So we can do 1 divided by 2, then these 2 gets cancelled. V1 square by V2 square it is equal 4 minus 5 by 2.5 minus 5. Already you know V1 by V2 is equal 2. Therefore V1 square by V2 square it is equal 2 whole square. It is nothing but 4. right? 4 it is equal 4 minus 5 by 2.5 minus 5. Just we can do cross multiplication. 4 into 2.5 minus 5 is equal 4 minus 5. 10 minus 5 it is equal 4 minus 5. Okay. Then 6 it is equal minus 5 plus 5 it is equal 0. Sorry, 4 minus 5 minus 4 pi here. 10 minus 4 pi it is equal 10 minus 4 it is equal minus 5 plus 4 pi it is equal 6 it is equal 3 pi 5 it is equal 6 by 3 it is 2. So 5 it is nothing but what is the 5 here? It is the work function. Therefore work function in this case it is equal 2 electron volts in terms of 2 electron volts. Very simple. That is right. So this is the last question which was asked in 6th September shift 1. Okay. The question it is an electron, a doubly ionized helium ion that is He++ and a proton are having the same kinetic energy. These three particles having the same kinetic energy. The relation between their respective de Broglie wavelengths. What is the relation between these three ions from these four options? Here one thing you have to remember, the kinetic energy is same. Okay. So from the de Broglie equation you can write, so lambda is equal to h by p, it is equal to h by mv, it is equal to h by under root of 2me. So from this you can write lambda directly proportional 1 by root m. 1 by root m, because of E energy is same for all the n's. Remaining the factor it is only mass. So if mass will be increases, the wavelength should be decreases. From these three ions, these three particles, which particle having the more mass? That has less wavelength. Okay. So what is the? So the doubly ionized helium has the more mass. So mass of the helium is greater than mass of the proton is greater than mass of the electron. Okay. If the mass will be increases, wavelength should be decreases. So hence wavelength. So wavelength of the, if mass will be increases, wavelength should be decreases. Okay. So you can write, how we can write that? So wavelength mass should be decreases. The mass, helium ion having the more mass, helium ion having the less wavelength. Okay. Lambda He++ is less than lambda P is less than lambda E. Okay. So this is the relation. Lambda He++ is less than. So here this can be written as lambda E is greater than, lambda P is greater than, lambda He++. Right? So this one, option C is the right answer. More mass, less wavelength. More mass, less wavelength. So helium ion, more mass, proton, less mass, very less, electron, very less. Okay, this is the option. Right. So these are the questions which are from the dual nature of radiation and matter. So please focus on this type of questions and you should get minimum marks in the 2021 exam. You have to follow our channel daily and you will get definitely minimum 80 to 90% of the marks in the upcoming JEE mains exam. So please subscribe my channel, please support me. Thank you one and all.